it's Mr. Van Dong here with week 2, day 2, math instruction for you for this distance learning thing we got going on right now. And we are, right now, if you're looking at this and thinking, wait, lesson 4, we skipped lesson 3. Yes, we'll come back to lesson 3 later. We rearranged several things in this chapter so that it makes better sense. And there's going to be like a bonus lesson. And the way that we do measurement is just a little bit different than the way the book has it laid out. So we are indeed on page 819, lesson 4. Now, the name of this is Estimate and Measure Weight. And it talks in a lesson about busting out a balance scale to measure and compare weights. And right now you might be thinking, I don't have a balance scale. And you don't. And you know what? The balance scales they give us to use are so bad that even if we were in school right now, we wouldn't be using them. They're not accurate at all. So what we're going to do here is we're going to tweak this lesson a little bit. We're going to skip a lot of the warm-up problems. We're basically going to go right into the key concept of measuring weight in the customary system with the conversions, and we're going to have an extra day of practicing the conversions. But before we actually convert, we're going to make a prediction. So that's going to be our estimate. Try to see, hey, do we have a good understanding of how many ounces something might weigh or how many pounds something is? And so we're basically going to guess on problems, and then we're going to check our work. And that's going to be the bulk of what we're doing today. So weight is something that we measure, and we're talking about weight on Earth before anybody is going to be a smart aleck and be like, weight on the moon is different, or if we were measuring these weights on the International Space Station, they'd all be 0. You're right, it's true. Yeah. But we're just talking about Earth weight right now. And when we get to mass later on in the metric system, we'll talk a little bit more about like outer space and how that applies to this. This is just weight, and the customary system again is makes total sense, right? You know, there's going to be 10 ounces in a pound, and then like 10 pounds in a ton. No, not even close. Not even. It's ridiculous. So, how many ounces are in a pound? Anybody? Huh? Anybody know? 16. It's 16 ounces in a pound. Why is it 16 ounces? I don't know. Because somebody made it that way in like 1400, and we still use it. So yeah, you got to memorize that. You got to memorize 16 ounces in a pound. How are you going to memorize that? With your brain. Now, here's what gets really tricky. Pretty soon, we're going to be jumping into capacity, which is how much fluid fits in containers. And in the customary system, there's also something called a fluid ounce. And when we're converting fluid ounces, the conversion is not 16. So I'm just warning you right now, there's ounces in weight, and it's 16 ounces in a pound. And then there's fluid ounces and other stuff later, and it's never 16. So anyway, 16 ounces in a pound. You got to memorize it. Maybe like sweet 16, like I'm going to be driving when I'm 16. It's going to be so cool. Let my hair down. I don't know, whatever it takes for you to remember that 16 is important with the measurement of weight. Actually, 16 works pretty well. Remember the whole like 16, I'm going to relate the measurement of weight to driving. And you'll see why in a second. So how many pounds are in a ton? 20? 35? 82? 2,000! There's 2,000 pounds in a ton. We jumped from 16 ounces in a pound to 2,000 pounds in a ton, and there's nothing in between. Actually, there's this thing called a stone that nobody uses. Thank goodness. But yeah, there's like no in-between thing in here for weight. So pounds are pretty useful for measuring a lot of things. If something's really small, you're going to use ounces. If something's like medium size, you use pounds. And if something's really big, we use tons. So something that weighs an ounce would be, let's see, what's the book's example? An ounce might be like a really thin slice of bread is an ounce. So a loaf of bread, if it's 16 slices, that would be a pound. Now, if you get like the thick, seedy bread, it's going to be more than a pound. If you have a scale in your house, it would be great to use it today to try to like weigh different things. If you have a scale that's meant for like measuring human weight, it's not going to be very good at measuring a small, something like your math book or something, which probably weighs about a pound. It's not going to do a very accurate job. If you have a parent who has a smaller scale for some reason, like maybe for measuring mailings that they do, or for measuring knitting, or I know fishermen use scales sometimes. If you've got something like that, bust it out and experiment with it and see how much different things weigh. But today we're trying to get a general idea of how these things kind of relate together. Oh, a ton. I said to think about cars. A very small car would weigh about a ton. A small car, like the little Mrs. Mendoza's little chicken mobile that you see driving around, right? That from Wingman. That probably weighs about a ton. So a car like mine, like a little Corolla, probably 2 tons. You start getting into like big trucks, and there's many tons of weight in there. So that's cars are, a small car would be 1 ton for your understanding. And when you're 16, you could drive a small car, and there's 16 ounces in a pound. That's what I got for trying to help you memorize these ridiculous numbers. Let's, so here it wants you to measure things, so skip it. Boop, 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 turn the page. And then here it's like, measure some more things. Skip it. And then it's like, hey, let's talk about those measurements. No. So we're going to jump all the way to page 821. And again, they want us to weigh things, and we're skipping number 4 as well. We're starting with number 5. So on number 5, most of the problems we're doing here are comparison problems. It's wanting us to compare 46 ounces to 3 pounds. So if I've got 46 ounces, which is abbreviated like that, compared to 3 pounds, which is abbreviated LBS. Don't ask me why, because I don't know. I looked it up and I can't remember, but anyway. So the question here is one bigger than the other, or are they equal? Now, first of all, using your brain to think about 3 loaves of bread or 3 math books and what 46 ounces might be, so 46 slices of bread, make a prediction now about what you think it's going to be, and just write your prediction underneath it, not in the answer space, but in the prediction. When I glance at these, I think they're going to be pretty close. So I'm going to guess that they're equal. I don't know. And I really don't. I haven't done the math yet. So I would guess they're equal. And now I'm actually going to do the work of finding out if one is larger than the other. So this is similar to converting the customary units of measurement. I need to think, okay, to make this comparison, I need both of these to be in pounds or both of them to be in ounces. I could group the 46 ounces into groups of 16. Because every group of 16 ounces is 1 pound. So that's how I would convert the ounces to pounds. That would be division. And you all know how I feel about that at this point. I would much rather do this other one. This is 3 pounds. That's 3 groups of 16 ounces. I would much rather do 3 groups of 16. So I'm going to do 16 times 3. If I'm going to use mental math, I do 3 times 10 is 30, 3 times 6 is 18, and add them together. If I'm not using mental math, I'd go 3 times 6 is 18, and 3 times 10 is 30, plus 10 up there is 48. Okay, so now I can basically cross this out. I'm literally going to cross it out to show my work, to show that I understand that this is 48 ounces. So what's bigger, 46 ounces or 48 ounces? 48 ounces. So 46 ounces is less than 3 pounds. Because 3 pounds is the same thing as 48 ounces. Mr. Van Dong, your prediction is wrong. Actually, my prediction, I feel really good about my prediction. They're only different by 2 ounces. So my instincts of they're going to be really close, I'll guess that they're equal, was actually a good one. As you continue to go through these, your estimates, hopefully over time, will become more and more accurate. As you start to think, okay, 3 pounds, 46 ounces. On the next one, you've got 96 ounces and 6 pounds. So there's quite a bit more ounces and just and double the pounds. So I'll let you keep working on those. So you're going to finish this page with comparison, and then on the back side, if there are any problems that ask you to actually measure weight, you may skip them. Anything that doesn't ask you to measure weight, you do it. Okay. If you've got a scale in your house of any sort, that'd be a nice thing to do, is to play with some, how much different things weigh. You can also figure out how heavy objects, if all you have is a scale for measuring a person's weight, one thing that you can do, like this is the way that my brother and sister-in-law see how much their young child weighs. They stand on the scale and then they pick up the baby, and then they do the math on the difference between their weight and their weight plus the baby's weight, and then you can use subtraction to figure out how much an object weighs. So if your scale isn't sensitive enough to just naturally weigh something really light, it probably would be sensitive enough if you're standing on it, and then to grab that weight and then to compare those two weights, and then you'll know how heavy the object is. So play with measuring weight today if possible, and if possible or not, do these comparison problems, making predictions as you go. And yeah, we'll see you tomorrow.